programmable logic devices, as the programmable logic devices name suggests, it is programmable, it is changeable. I can change it to program it to various type of logic devices. So it can provide different logic function. So what you can see, first thing what you need to know is programmable logic array. The short form is PLA. You should remember, because later you will get PAL also, which is different from PLA. So programmable logic array is it's an array which has an AND array first and then OR array. So when you have AND array first and OR array later, means what? It will be able to implement sum of product. Product will be done at AND here, and then the summing will be done here. So this is called as programmable logic array. So any Boolean function, your ANDing happens first. For example, A, B, C, or A bar, B, C, or however, that ANDing happens here. And at these wires, you get those ANDing terms. And whichever terms you want to or add, so that comes here. So this is the basic structure of programmable logic array, that is PLA. Now you will see further. This is a diagram. All of you see it very, very carefully. You know that you have been doing this, no? A bar, B bar, C bar, like this. So inside programmable logic array also, an example is being shown for a 3 input. So what you can see, the first line, you see what is happening. First line shows that there is a connection made here, and this connection with this arrow, what you are able to see, this is done by the programmer. For example, if I have to do A bar, B bar plus AC, can you see this F naught here? If the programmer has to do this F naught, A bar, B bar plus AC bar, what this programmer will do? The program will go to this A bar line and this B bar line, and it will fuse it here. Fuse it here means connect it here. So first row here will belong to A bar and B bar. Why? Because this is the AND array. This is an AND array, and A bar, B bar, because I fused or connected A bar and B bar, I get a bar, B bar here. Okay, same way. Now you can see what my second line is doing. You can see here A is connected and here C bar is connected. So this second line is dedicated to AC bar. Same way, what is my third line? Third line is just a B. There is no ANDing happening. So only one is fused or one is connected. So you get a B here. Second last line is what? B here and a C bar. And last line is A and C. So what I can see, my AND array gave me A bar, B bar, AC bar, B, C bar, AC. And if I want more such things, more rows will come into picture. So each row is responsible for one product term. So you can see here, this AND is there. This AND, these rows take care of ANDing operation. So here this ANDing operation only has happened. So after this AND array, what all I have? I have these 5 terms. I have these 5 terms. Now which terms has to be odd or not will be decided by this OR array. You saw that AND array is a horizontal business. OR array is a vertical business. The same is shown here also. AND array horizontal lines, OR array is vertical lines. So what is happening here now? F naught. F naught, as I told, it is A bar, B bar plus AC bar. So what does it do? F naught line will take this A bar, B bar and AC bar connected. So you can see till here, left hand side of this was what connection? It was AND connection. Now right hand side, if I want F naught, I will connect first row and second row to this F naught vertical line. I am connecting the first row and second row to the F naught vertical line. So this F naught will now give me the expression of A bar, B bar and AC bar. Same way, what is F1 now? From this you can see and tell me. So all of you try to tell me what is F1, F2 and F3. Analyze and tell me.
Ma'am, so each of the diagonal connection is the connection between one variable and the other variable, ma'am.
Yes, right. It is not one variable and other variable. It will be the ORing operation. So F0, if I do this connection, it is giving a C bar contribution to this F0. And again, if I want AC bar contribution to F1, I should do this connection again. So this
Yes, ma'am.
F1 will take this AC bar now again. And along with AC bar, it wants a B. So B connection will happen again. So F1 column will take care of its respective connection. And this connection is contributing to this AND term. So horizontal, this connection contribute to this AND term. Vertical, this connection contribute to this OR term. Okay.
Ma'am, what does the direction of the arrowhead imply?
See, direction of arrow does not imply exactly anything. If you simply put a line here, that also says that fusing or connection has happened. But just to show you people the difference, the ANDing operation they have done with left direction and ORing operation they have done with the right connection. Because this is first time to signify they have done like this. But actually, practically speaking, in the real world, it is just fusing or connecting. So the arrow does not mean anything that time. But for the time being, you can take that left direction is ANDing operation and right direction is ORing operation.
Yes, ma'am.
Okay. Now you people can observe and tell me what is F1, F2, F3. Anyone?
Ma'am, F1 will be A C bar plus B.
Okay. F2 and F3, somebody fast.
F2 will be A bar B bar plus B C bar.
Correct, very good. And F3 is B and
B plus AC.
AC, correct. So you are able to get your F0, F1, F2, F3 with this connection. Now, either the examiner can give you F0, F1, F2, F3 variable Boolean expression and will ask you to make this PLA, or there is one more way of doing. See, this is what you people have been doing. This is AND or array equivalent of this PLA. You all know this. The same is depicted here in the form what you people know. So here horizontal AND has happened and vertical OR has happened. So this is just to explain things easier. Now there is something called as PLA table. Now I will explain you what is PLA table. Now all of you can see this table on your screen. This table says what? The examiner may give you just this table also. And a table, A bar, B bar is depicted like this. A bar, B bar and C is a dash. You all know dash means it does not contribute. So A bar, B bar and you have 5 product terms. So 5 product terms are shown like this. A bar, B bar, A, C bar, here B, here B, C bar and here AC. So product terms are written like this. And your 4 F0 to F3, 4 output terms are written like this. You saw in your PLA diagram that F0 was taking A bar, B bar and AC bar. So what did they do? In front of A bar, B bar 1 and in front of AC bar 1 they have given. Rest is made as 0. Same way F1, F2, F3 is taken care. So this is called as PLA table. Very simple and straightforward. Any doubt in this?
No, ma'am.
Okay, so this is very simple. PLA table, if somebody gives you, you should be able to write this and implement it in the PLA, programmable logic array. Okay, so this is all about your table. Now you can see here the PLA table given like this and it is made like this. Now can you see the arrow has vanished now? There is no arrow now. These heavy dots are showing the connection. Heavy dots are showing the connection. So now the first row, what you can see, A bar, B and D is heavy dot. A bar, B and D. So you can see here A bar, B and D, heavy dot. So first row it contributes to A bar, B, D. Same way all rest rows are contributing to various things based on this table. You can see the second last row is only C. So this row is heavy dot only at C. So this shows that AND operation is taken care here and OR operation heavy dots on these vertical lines. So this is your OR operation. So this is your PLA structure. Heavy dot means connection. It is fused or connected. So this connection does not bother about the arrow, but okay, no problem. If you are making it that way, you can use that arrow direction. But here heavy dot means connection. So that means what? Facility to put connection anywhere is given. But based upon my requirement, we will do the connection and we will program our PLA in whatever way we want. So is this clear now? Simple and straightforward. PLA realization of this table. So this simple thing you can get in your exam also. Can I proceed further? Is it clear?
Yes, ma'am.
Okay. Now, till now you saw programmable logic array. Means you saw that you had and then OR. Now you have to see a different one. That is programmable array logic. Now programmable array logic, what happens? Things changes here to some extent, not much. Now what you can see here, we are having only the lines here and your and OR comes like this. So the programmable logic, programmable array logic facility is given like this. You will have a certain number of input gates. So your and OR are shown like this. Let us go to down. See, this is a PAL. How does PAL look like? PAL, programmable array logic, looks like this. Now you can see that you have this one and this and is connected to one line here to show. And what is this one line here? It is connected to X bar, then Y bar, and then C. You all remember, na? Sum and carry this thing of a full adder. So X bar, Y bar, C. So X bar, Y bar, C is connected to one line. So this and, this first and is giving me this product term, X bar, Y bar, C, and so on. And all these are summed or odd in a last line. Okay. Now you can see sum has 4 terms and carry has 3 terms only. But your array structure will be same, na? So what is happening? This array, this programmable array logic is capable of taking care of 4 terms only at the max. So 4 and terms are here. In this case, last one is not used. So they have not done any connection. So it is given, the freedom is given to the programmer that if you don't want this term, this is not connected, simple. Okay. So there is a small difference between programmable logic and programmable array logic, and you should be able to implement given whatever. Is programmable array logic clear to all of you? So here the connection is shown with this cross. If cross is there, connection is there. No cross, no connection. So this last row you can see no connection. Okay. So this is your programmable array logic. These two are only main things. If you understand this, rest other things are theoretical, nothing much to do there. Is programmable array logic clear to all of you?
Yes, ma'am.
So here what you can see, your NOT gates are shown like this, and vertical lines are there for a variable and a not of that, a variable and not of that, like that. A cross shows the connection, no cross, no connection, and you get a array of and then OR. Okay. So this is little simpler. This is advanced than that one, programmable logic array, PLA. Now CPLD, this is theoretical topic, but still I will explain a little bit so that you people find it easy to do. Now what you have seen, you saw that your input and output were connected in certain manner. Those things are connected together here. So complex programmable logic device is CPLD. Okay, see the name, complex programmable logic device. So this has many such arrays. Okay, this has many such arrays, and now you can see 36 bits here, 16 bit here. So this is interconnect array which will be connecting between various function block input and output. So this array is able to take the 16-bit input and it is able to give the 36-bit output. More complex operations are done using such CPLDs. So this is all one CPLD in detail is shown here. This is array of many CPLD. You can see this architecture. It is available in market, XCR3064XL. But anyway, you people are not using it. You should just know what is inside CPLD. So one CPLD function block is shown here. This part you know already. This part you know already. And or. Now, one thing what you need to know is combinational logic circuit. The output is available at that moment only. It can't be stored. But you also know that a flip-flop can store one bit value it can store. So CPLD has this D flip-flop here. So this D flip-flop has capability of storing that 1 bit. So this output is stored forever till you erase it. So the CPLD comes with a extra flip-flop which is there to store. So this is called as simplified macro cell. It will be storing. This flip-flop is storing, and this is giving extra power to this array. So this becomes your CPLD. Okay. Last you have field programmable gate array. This is something which comes like this. Why it is called field programmable gate array? Because again it has so many arrays only. So many arrays, input output block will be there, interconnect area will be there, and because it is in a row and column form, it is called as array, and it can be programmed by the programmer in the lab. That is why it is called as field programmable. Field means wherever you like to program. In the lab, in the any working area you can program. That is why it is called as field programmable gate array. So this is just giving you a simple diagram of a field programmable gate array. This is simply trying to show that how your combinational logic will be. You can see that multiplexers are connected. Your combinational logic circuit is shown in the LUT. LUT is lookup table form, and to store your output, this D flip-flop is there. So this is typically showing what things can take care. It is combinational logic, then giving the interconnection between the various input and output using mux or however, and you are able to store that also for some time using your flip-flop. So such complex logic devices consist of your arrays, multiplexer and D flip-flop. Okay, now here this is something called as implementation of lookup table. Again, this is something what you have seen already, A bar, B bar, C bar, D bar, because this is 0. You can see here, it is 0, function is 0, so it's coming here like this. Now, I told you that each one is able to take care of 4 variable only, A, B, C, D, 4 variable only. What to do if I have 5 variable then? What to do? You remember you have taken care of your 5 variable K map using 2 K map with A equal to 0 and A equal to 1. You remember that? So that A equal to 0, 1 4 variable K map was taking care. A equal to 1, another 4 variable K map was taking care. So this 5 variable was decomposed into 2 4 4 variable by A equal to 0 and A equal to 1. Same thing is done here. See, decomposition of switching function. So A, B, C, D can be decomposed as A bar with BCD here and A with BCD here. So this decomposition can happen between 2, just like I am trying to decompose things for 2 function. So A bar F0 became here and A F1 become here. Okay. Now what they are trying to show with this A, B, C, D, and you can see how we can decompose. You can take your equation and you can take A bar common to whichever you have and A common to whichever you have. Okay, so you can look into this equation later because it is already time up. Okay, so then this can be decomposed. You saw this, A equal to 0 and A equal to 1, how 4 variable is getting decomposed into this. I want you people to analyze this, and if you don't understand, I will take up in the next class. Okay, so this is how a 4 variable is decomposed into 3 variable. Same way, a 5 variable can be decomposed into 4 variable, which you have already done in your 5 variable KPAP. And then your 4 variable array can be used, and then it can be 2:1 mux can be used, and the complete function comes. So this finishes your CPLD PLD topic. I want you to go through this, and if you have any doubt, you can ask in the next class. Next class, I will take the doubt of this. All of you have to read it before asking me doubt. And then we will finish off with the look ahead carry adder. Okay. So this is already quite late for today. Okay. So let us meet in the next class.